Hello, my name is Gabriel and welcome to a new video of the Concierge series. In this one, we have to discuss a little bit the architecture of the platform. We got to the point where the proof of concept starts to work, so we know that we would like to evolve the platform. This session will be almost no coding, just decisions and explanations. A common problem with Vibe projects is that they are insecure, but this is not necessarily a problem of the vibing itself, it's a problem of the architecture. There is a reason why the system architect job exists, and there is also a reason why juniors are not usually system architects. With vibe coding, almost every junior has access to decent quality code if prompted properly and not using a very bad model. However, there is a lot of knowledge missing, and when we develop a new feature, we either have the knowledge in our heads, either use a very big army of agents. There are two problems with the army of agents. First is that they are stuck in time. Second is that they don't understand. They don't correlate things. They just explain and they make themselves believe. If there is conflicting information in the documentation used in the training process, this conflicting information will result in conflicting sentences that end up nowhere. Also, there is a true possibility that the documentation version on which the model was trained is not the latest. Then there are the subtleties found in these documentation that still require intelligence in the sense that, yes, you can infer from the documentation how it should work and why it should work, but the LLM itself will not make the decisions instead of you. You still, as a person or as a manager or however you see yourself, you have to drive the system. And if you don't drive the system correctly, it is not going to drive itself. At best, it will perform fairly fine. It will produce something usable, but it will not drive itself. So security in the sense how it is presented on the internet is not a problem of the model. Most of the times it is a problem of the architecture and of the humans in charge of these models. And this is the case for us. Until now, we have created a website, which is the red box here. And this website is split in two parts. We have the front end part on top and the back end part on the bottom. And this is all we had. We've made it even worse. Here to the right, between the two of them, here we have introduced an LLM. I'll put it with a question mark because we don't know which one will be, so we cannot target something specific. In the end, we just made tests with some, and it is a layer of uncertainty by itself. It comes with uncertainty. We have users. We believe, or we want to believe, that these users will all follow the front-end part. But if we are to release this project, nothing almost stop them from targeting the backend part. In the way that we have designed the system right now, they can see the calls that are being made and they can make new ones by themselves. So this is what we have now. Now we need to protect ourselves a little bit. We need a mechanism that allows users to target only front end, blocks users from targeting backend unless necessary, and to make it agentic for today's day and age, we also have to allow LLMs to target the front end. Now, as we have seen, when it comes to tool calling and LLMs, they don't come with one request every now and then with the speed of a human. No, they come with a bunch of them really, really fast. Our architecture is wrong. What we did has to be improved. So how do we improve it? We have to decouple this front-end part from this back-end part in a way that supports multiple layers in between. Here in the final goal, we will have to have some sort of cache. Under this some sort of cache, we should have another block. This one is security. Why do we need a security layer under the cache? Because there will be requests from frontend that have to go over the cache. They have to bypass the cache and reach the backend directly. One example of such services is anything user session related. That one cannot go through cache. In cache, we can put hotel information or things like this, public things. Since this is a closed system deployed inside a hotel, that is the use case. But maybe some user can update just some of the rooms and another user can update other rooms. Therefore, we need to support this type of functionality. Now, over front end here on top, there is another layer of security. Why this layer of security? Because based on the user which is logged in currently, some of the information should not be visible at all. Some of the buttons should not exist. Some of the pages should not be accessible, so on and so forth. By having a security layer on top of this, we are allowing the front end to function more independently only by hitting the cache if necessary, without having to hit the backend all the time. Because underneath the backend, we also have our database, and this database is in direct communication with the backend. So by lowering how much information reaches the backend, we lower the load on the database. Basically, everything that comes from top to bottom, every time it hits a new system, it creates a new workload. A front-end request, which is not stopped at the front-end level or front-end plus cache level, will create a new work on the backend and will create a new work on database. Even if these are different computers, even if a front end is our laptop, the backend is a server, the database is a different server, the problem still stands. We just create work down the line and we expect somebody else to solve it. So in order to solve it ourselves as soon as possible, we have to create security. Now, security for the database can be done, but in this case, it is easier to abstract and never make it public. If we need to make it public, it should have its own little block. Now, in order to solve the security problem, we have some solutions. We can implement it ourselves 2 times, 1 time here and 1 time here, or we can use an existing solution like Keycloak. Now, in Keycloak, there is a big portion of user management. It is a product defined for this. It is an industry standard. It is an open source product with a lot of sponsorship, and it remains open source because for the ISO certifications, it is important for it to be open source and auditable. So what we can do, we can use Keycloak. Then under Keycloak, we can implement a client in both parts that soon as a request comes to frontend, there is a token, the user gets authenticated in Keycloak. As soon as there is another request coming for backend, there is a different token. The user gets authenticated. But in reality, the user is the same human. So if this is our great person, he is just one. It doesn't make sense for him to authenticate in both parts. But it does make sense for him to have access rights. He needs to have access to some things and be denied other things. So we should put another brick here, which handles one communication with Keycloak. What will the user do? The user will hit frontend. It will hit the security layer of frontend. Will check and do a redirect to this. We'll call it a reverse proxy. Doesn't really matter which reverse proxy we use. Frontend will redirect to the reverse proxy if there is no authentication currently available and the page requires it. And that's all. That in the reverse proxy will talk with Keycloak and it will ask if the current session has information about this user. The user will be presented with a new page, a standard page that comes from Keycloak with a login information part. The user authenticates there properly and then comes back. And from this moment on, this user is logged in. As soon as the user makes a manual request to the backend, the user can choose to add its token on that request, and the user will remain authenticated. So from the user's point of view, he has just one entry point, the reverse proxy. The reverse proxy does not store confidential information. Keycloak will store this information, and Keycloak is encrypted, and Keycloak is very secure. Then Keycloak comes with users, user groups, permissions, anything you can dream of. So we can maintain a list of groups with URIs where they have access to, or resources where they have access to. And in frontend and in the reverse proxy, we can make a validation. If the URI that is being requested right now is not in the list of URIs available for this user, then the reverse proxy itself will deny the access. Like so, we don't have to code in both places the list of URIs. We just have the reverse proxy that is handling everything. And that makes us have a much more clean architecture of the system. We can continue developing Concierge OS in the way that we were doing now, with as much freedom as possible, while still having top security with a reverse proxy. There in between can also be Autohash. In our case, is not required. Autohash is required usually when we transfer a session from one application to another. Currently, we don't have multiple applications. Could be the case if we develop a new application for scanning IDs, then in order to block the user from using the ID scanner application, we can use the Autohash proxy to log in this user on the phone as well. It is a possibility. The other possibility is to block the phone from sending data to the backend without a session. Both work, both have advantages and disadvantages. Usually the best is to block the application, because that covers also what happens when the user is outside of the hotel's network. While it's inside the hotel network, everything, if we use internal IPs or internal domains. But by using an internal DNS in the communication between the reverse proxy, Keycloak, or the hash2, and the ID scanner, we make sure that when the user takes his phone outside of the premises of this hotel, he cannot use the application for anything. The application will just not load, not work, not find the server. This is even better when the phone is lost. So this reverse proxy will also handle that. It can be done without all the hash2 for sure, but with all the hash2, the user will be logged in seamlessly across our devices and applications. So it will be better. It will just work across. Now, let's talk a little bit about the agents that are hitting the front end. I think they will come from unexpected sources. I think it will also be the browser that the user is using, because as more browsers and operating systems are deploying local models for things, they will start doing crazy stuff. I don't think that we can stop this in a reliable way. I think the world is moving in that direction. We ourselves, we are developing an application where we allow the user to configure the way the front end looks like. So it is silly to assume that the others will not do the same thing as we do. So it is best to prepare for the worst. Now, let's talk a little bit about the caching layer. The caching layer can be anything, because almost any database can store a JSON. We don't need to look into the JSON. We don't need to do updates in the JSON. We are not worried about that. We just need to cache the most common information. The request that should be cached will come from either the front end or the LLM itself. The problem is the invalidation mechanism. A while ago, it was more easy, because the invalidation for requests is kind of standard. The invalidation for GET requests, usually it's made based on the URI, and it was caching the whole outcome of that URI. All the work done on the server was being cached there. In our case, since we give freedom to the LLM to run things, the LLM can bypass this cache, because the LLM in reality is not where we've put it. It's the wrong place to be. The LLM is here. The backend makes a request using the Open API standard and library to the server where the LLM exists. Now, at that point in time, the LLM is injected in the scope of the request that came and is inside the code of the backend. In the previous architectures, when frontend was requesting something from backend, the frontend was sending the request and then was job done and was just waiting a response. Now the frontend is sending something to the backend. Backend says, hey, since I need to talk with this LLM, I will just include this LLM with its capabilities inside me. And every time the LLM requests a tool call, I will let it run things inside me until I'm done with this work and I can send it back. So the LLM will not hit this cache that we are talking about. In order to make the LLM hit that cache that we are talking about, we need two backends. We either move the LLM to frontend, which is very unsafe because if we do that, the frontend will exist in the browser of the user, and a malicious user will be able to manipulate that LLM. So we don't want to do that. We want to have it lower. We need a new backend inside. So we need to split the backend into two. And in between those two, here's where we have to put cache similar to that one. So from top to bottom, frontend hits the cache based on the URI as usual. From backend to backend, when talking to the LLM, the backend hits the cache for the LLM when the LLM asks things. We have the tool that we've made in the last episode, which allows the LLM to perform database operations, mostly reads. That tool should not talk to the database directly. That tool actually should communicate with this, because every time this tool is fetching information about users or reservations from the database, that tool has to cache it for frontend as well. We can retrieve super fast by hitting the cache. And if we don't find this information in the cache, we go to backend. The backend manages the translation for Ahmed's name with the help of the LLM. And then when the LLM talks with the database to retrieve and build the content of the request, that content should already be cached, because on the second request, it should be available for frontend as well, not only for the LLM. There should be that layer. And moreover, there also has to be a different type of security here. The LLM itself doesn't need to have a keycloak user, but the LLM itself has to have restrictions. As we've seen yesterday, different models operate differently. They ignore instructions in different ways, and they choose what to do in different ways. So here, in the same way that we were coding our tools yesterday, we have to have a set of tools exposed to the LLM, which is not a full set of tools exposed to the humans that use the frontend. For example, a human can delete a reservation or cancel a reservation because the human is accountable. This section here is the accountability. Our accountability comes for granted in frontend, because this accountability comes with a work contract and with backups and things like this. In the case of the LLM, there is no work contract. It's a piece of software which has the same liability as a human, without the control that we have over a human, and without the understanding of a human, in the sense that the human understands that it needs food and salary. So it will refrain from doing stupid stuff. The LLM, it will do stupid stuff in the name of optimization. For example, if it sees that the database is running slow, it might think that it will do good if it removes some of the reservations. It is not even a false claim. The LLM, it's actually right. If the user in the front end complains that the system is slow and we allow the LLM to self-optimize, it can choose to clean up the database, and it is not wrong about it. The human will not choose such thing, because the human understands that if he does that, he's out of work. So this accountability layer has to exist. We can see the LLM as a totally different frontend, but a more dangerous frontend, because it's not outside of the application, it's actually inside. So what we have to do, instead of using Open API and target directly the LLM, we need to handle this separately. We need the backend to talk to a service, and that service has to contain the cache, the green cache for frontend, and the green cache for LLM. So it needs to contain both caches. And that service also has to have a part that handles the accountability, the white thing. For users, the accountability will come from Keycloak. For LLMs, the accountability will come for LLMs, the accountability will come from the tools that it is not exposed to. So if the LLM is exposed only to reads and things like this, it should be safe. Although it is safe until it is not safe. Imagine that you have 3, 4, 5 hotels, and each employee should have access to the reservations on only one hotel. That's super easy to implement with Keycloak. You just restrict the URI. doesn't have read access. Job done. Now, the LLM, in order to function, has to expand these roles because the LLM has to take from the users the properties where the user has access and then have to create the request in such a way that it cannot request information from hotels where the users don't have access to. Now you can say that this can be filtered in backend. And you are right, it can be filtered in backend, but it needs to be filtered in a smart way. It needs to be filtered in the security layer here. So right under security layer. The security layer will come from Keycloak and it will tell us this user can access rooms. Then in this security layer underneath, we need to make sure, can this user access rooms of that hotel? And if not, we don't do any LLM work. But what happens if you create a web page in frontend where the prompt that you're giving says, give me information about all the hotels? That request will bypass our security because it's an URI where the user has access. It request information, request rooms, whatever you want to call it, get rooms, will bypass the second security layer because that that user has access to our rooms. But inside the LLM will explode because the LLM has access to all the rooms. And that is a security problem. This is why when we expand the accountability, we have to put the accountability before the caching. So first, we need to validate that this information that the user just requested should be something that it can be retrieved. If it's something that can be retrieved, it should be coded in a way that the tools presented to the LLM are specific enough to not work across the accountability and across Keycloak. So we don't want to make an endpoint that says get our rooms. We want to make 5, 10, 11, 50 endpoints that says get rooms from hotel 1, hotel 2, hotel 3. And in order to compose the get our rooms, the LLM can request, hey, give me 1, 2, 3, 4, 5, blah, blah, all of them, because it's crazy. But our accountability and our security layer will block everything from one. And in order to trick the LLM into not becoming more creative than necessary, the block request should return empty objects, not errors. An empty object, so the correct format, but empty, will tell the LLM that there is nothing there. And the LLM will not try to look further. If we return to the LLM an error, the LLM will think that maybe I did something wrong. Maybe I should try to bypass this error. So you don't necessarily want to poke you don't want to annoy things when not necessary. So this is the architecture that we have to implement. We need more layers of security. Comparing to a normal application, we have two access vectors. Comparing with a normal application, we have the frontend, where is the human, and we have the LLM, where is no human, but the restrictions have to apply the same. We need two layers of cache that work in tandem. In reality, it will be just one with a microservice that are accessible by both. And they are hidden beneath the security in different ways. So from frontend, it will be a reverse proxy. And inside the backend, it will not be reverse proxy, but it will be our white layer of security. And we need reverse proxy plus Keycloak plus probably OpenAuth. We'll add OpenAuth later down the line for the ID scanner, because the ID scanner we can restrict easily in the beginning by using an internal DNS in all this communication. So how it would look like, old guy will open the website. The website has no session or anything, so something super basic. The website says, well, I send you to the request proxy to authenticate. The request there in the request proxy web page, which comes from Keycloak, the user will authenticate. Keycloak will give him a token with the permissions that he has access to. He returns to the frontend. Based on these permissions, frontend will react with what has to be visible. And there, the user starts working with what it has access to. And at the end, our database, the choice that we've made now, it was the easiest. But it doesn't mean that it will remain like this. Because if we will turn into a write-heavy system, we have to do some improvements there as well. But for now, it works. We can change it later. Good. So this is a discussion about privacy, security, legal liability, and how all this should tie into a system architecture. So on this note, Thank you very much for watching. And starting from the next episode, we will refactor the frontend to be more split apart, and we will start working towards this pattern while still testing LLMs. So once again, thank you very much for watching, and see you in the next episode.